Good day, grade 10s. I hope you are doing well and that you are ready to focus a little bit. In this video, we will be taking a look at linear inequalities. Now, considering linear inequalities, it's not too different from linear equations. The big difference at the end of the day is just the signs that we use. Now, if we go to the next slide, this will be. Now, what precisely is the difference between linear equations and linear inequalities? First of all, linear equations, you are working with, oh goodness, that is very dark, if we work with equal signs. If we work with inequality signs, such as these signs over here, then we know we are working with inequalities. So big difference between equations and inequalities is that the one uses equal signs while the other one uses inequality signs. Another difference as well is for linear equations we get specific answers, meaning you know that your x value is definitely going to be 3 or your x value is definitely going to be -4. While with linear inequalities, your x value can actually be any value that satisfies the inequality. So for instance, if I tell your x value is bigger than 2, then it means your x value can be 3, it can be 4, it can be 4.5, it can be 25, it can be any value that is bigger than 2. So with linear equations, we have specific answers, while with linear inequalities, we have unspecific answers. As long as the x value you use is just satisfying the inequality, it is a value we are allowed to use. Well, one of the biggest problems when working with inequalities is actually not the calculations. It is reading the inequality signs. Now, in primary school, you probably taught that there's a difference between the bigger than sign, greater than sign, smaller than sign. But all I want you to remember in a sense is to remember that the side to which the inequality sign is open, that is always going to be your bigger side. So meaning if I give x and then the mouth of the sign is open towards the x, then it means the x must be the bigger value. If I were to flip it around and make the mouth open towards the 4, like in this example, then that means your x value would actually be your smaller value. So the side to which your mouth is open of the inequality, that's always going to be the bigger side. So like I said there as well, there's an example. If x, then the mouth is open towards the x, then it means x is bigger than 2, means that x is bigger than, well, I already said it. And if the mouth is not open towards the x but open towards the 2, then it means x will be smaller than 2. Oh goodness, that's supposed to be an x. But it means that 2 is bigger than x in that case. Well, move on then to how to actually solve linear inequalities. It's not all that different from calculating linear equations. We do what we do with linear equations. So we get all of the values. Well, if we go to the points there, sorry. What we do on one side of an inequality, we still do on all of the sides of the inequality. When we isolate terms with the unknowns on one side, we still throw everything without unknowns to the other side. So our rules there, in a sense, are the same. But now there are two differences. We represent our final answer on a number line. Now, the reason for this is because we have unspecific values. So we don't have just one x value, we have a bunch of x values that we are allowed to use with inequalities. And if we divide or multiply with a negative number, then the inequality sign must flip around. So let's say, for instance, I had minus x bigger than 2. Remember, to get the x alone, we still have to divide with a negative. And because we're dividing with a negative, the inequality sign needs to flip around. And now x becomes smaller than minus 2. That is all that final statement means. Now, let's get on with some examples. The first example we have is solve the following inequality. Now, First thing we do, we try to get everything with x on one side and everything without the x to the other side. Now in this case, I'm going to throw the 9x over, so it becomes 3x minus 9x is smaller than 4, and we continue normal algebra. So 3x minus 9x, that gives me negative 6x smaller than 4, and like I would like to do with linear equations, I like to get the x alone. So I'm going to divide with negative 6. So x becomes bigger than minus 4 over 6. Remember, in this case, we have to flip the inequality sign around because I'm dividing with a negative number. Then we can just simplify. So x is going to be bigger than minus 2 over 3. So since x can be bigger than minus 2 over 3, that means on the number line, we can say, okay, minus 2 over 3, then, well, that's going to be smaller than 1, so then we have 0, 1, 2, for instance. My x values can be bigger than minus 2 over 3. So we just draw a number line, and then we indicate, okay, is my values going to be bigger than minus 2 over 3 or smaller than minus 2 over 3? In this case, remember that on the number line, if it's equal to, we use a closed dot, meaning if we have greater than and equal to or smaller than and equal to, we use a closed dot. If it's open, we use just bigger than or smaller than. Okay. Now we can get to a little bit more of a complex example. Again, we're going to have to end up, well, in this case we have fractions, so what we do in this case, we follow the same linear equation rules. We try to get the denominator the same on both sides. So we can put this 3x minus 1 over a 1. We can talk about our LCD in this case is going to be 2. So now we just make our denominators the same. So then we have the 2x minus 3 is going to be 2x minus 3 over 2 is bigger than or equal to, well, 3 times, well, we multiply with 2 at the top and the bottom there, so it's going to be 6 bracket x plus 1 over 2. The 6 comes from the 3 times 2, which gives me the 6. From there, I can forget about my denominators again. So 2x minus 3 is bigger or equal to 6 bracket x plus 1. From there, we just need to solve for x, so we get rid of the brackets. We multiply the 6 in, then we get 6x plus 6. And then from there, we can throw everything with the x over to one side and everything without the x to the other side. In this case, I'm going to say minus 3. I'm going to take the 6, throw it over, it becomes a negative 6. And then I'm going to keep the 6x on this side and throw the minus 2x over. Continue simplifying. This gives me 4x minus 3 minus 6 gives me 9 minus 9. And then I just divide on both sides with 4 to get my x alone. So x is smaller than or equal to minus 9 over 4. Remember, the sign to which the mouth of the inequality is open, that's always the bigger side. From there, we need to draw a number line again. So, well, we can use any values on the number line. So we can use minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. And in this case, if you type minus 9 over 4 into your calculator, it's going to give you 2 and a quarter, or negative 2 and a quarter. So it's going to be somewhere over here on your number line. And you know that in this case, we want our x values to be smaller. So it's going to go to my negative side of my number line. So I draw my closed dot because I have a equals inequality sign with the equals underneath. That's what the little stripe there means. And I just draw my line with my little arrow showing that I'm working with x values smaller than minus 9 over 4. So then we get to examples like these. Now in this case it might look a little bit complex and difficult, but all you need to remember is that what you do on one side of the equation or inequality, you have to do on all the sides of the inequality. And I almost want to say, never take the term with a variable and throw that around. Keep that as a last resort. So in this case, if I take a look at this middle one, that's where my x is. So I want to get that x alone. So to get rid of, or to get that x alone, first I need to get rid of this positive 1. Now to get rid of it, we would normally throw it over the inequalities or the equal sign, but it would normally just to one side. In this case, our inequality has two sides, so we take the 1 and we throw it over to both sides. So it becomes minus 5 minus 1, 10 minus 1. So I'm taking the positive 1 and just throwing it over both of my inequalities so that I can try to get the minus 3x alone. From there, minus 5 minus 1 gives me minus 6, which should be smaller than or equal to minus 3x, which is smaller than or equal to 9. From there, remember my goal is to get the x alone. So what I do is I divide everything with minus 3. Since I'm dividing with a minus, all of my inequalities flip. So my x value is going to be, well, minus 6 divided by minus 3 gives me 2. And my 9 divided by minus 3, that's going to give me minus 3. So in this case, my x value should be between 2 and minus 3. So on my number line again, we're going to have, say, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. My values need to be between minus 3 and 2. So I'm going to create a closed dot above the 2 because it was x is smaller than or equal to 2. And then for above my minus 3, I'm also going to create a little closed dot because my x value is bigger than or equal to minus 3. So I'm allowed to work with all the x values between minus 3 and 2. And ladies and gents, that's about it at the end of the day for inequalities. All you need to do is what you do on one side, you do on the other side. And if you still just want to get x alone, and if you divide with a negative, you have to do it on both sides. Or, oh goodness, if you divide with a negative, you should just flip your inequality signs around. Now, I want you on the exercise, the worksheets being handed out to you, I want you to do exercise 2.3.2 only. Question 1.1, 1.2, 1.3, 1.4, 1.5, 1.7, 1.8, and then 1.13, 1.14, 1.11, and 1.12. Okay, good luck.